Good morning and welcome to the forum at St. Bart's. My name is Peter Thompson. I serve as the Associate Rector for Formation and Liturgy here. And I'm delighted to welcome you to this final installment in the series of conversations we've been having over the past few months on the future. And today we turn to the role of technology and healthcare. And we're privileged to have with us Clay Williams, our very own Clay Williams, parishioner. He's the leader of the Living Christ Sangha here at St. Bart's and a devoted member of our 5 p.m. congregation. He's outside of St. Bart's. He's the founder and CEO of Medaptive Health, which is a health tech startup. He holds a PhD in computer science from the University of Texas at Austin and previously spent many years at IBM's Watson Research Center. And he also is qualified in the area of theology as well. He has a master's from General Seminary. So Clay, thank you so much for taking the time to be with us this morning and share this presentation with us.
Thank you so much, Peter. I'm really happy to be here, and thank you all for joining this morning to hear a little bit about tech and healthcare. So I'm going to share my screen and just set the context with a few slides that hopefully will engender a discussion and some questions about where we are and where we're going. I think I'm just going to skip over my first slide. Peter already talked about what I've done. I'm going to go straight to really thinking about when you look at medicine and healthcare, the aim is really to answer some very profound but simple to state questions. The first is, how does the body work? And so understanding how the body works is necessary to answer the next two questions. What is causing an illness? And then finally, and maybe the most important question, what can we do to restore health? And so when we look at the role of technology in healthcare, I'm gonna talk about it through the lens of these three questions. And if you look at the Middle Ages, the answers were very different than what we give today. The body works by being governed by what they called humors, and they sound kind of gross, yellow bile, black bile, phlegm. Disease was caused either by imbalances in those humors, or sin or witchcraft, somebody acting against you. And the treatments, the way to restore health, were either rebalancing the humors via induced sweating or vomiting or bleeding, prayer, or invocation of the saints. The Enlightenment came along and really switched the way we understand the body and disease. So today we would characterize scientists, the body as an electrochemical mechanical system. So there's a lot of electrical activity in the body. It's usually created by chemical activity, and that drives our body mechanics, moving your elbow, walking, etc. And disease is either caused by external factors, invasion of microbes, bacteria, viruses, funguses, or dysfunction of the body's systems. And that dysfunction is usually tied to a chemical process. That's really important because that talks a lot about how we try to return things to normal. So treatments are usually medications, and those may either be targeted to kill or suppress the microbes that have invaded, or to affect the chemical processes related to whatever is not working right. There are also treatments that focus on the removal or eradication of dysfunctional elements of the body. Think about removing a tumor or an infected appendix, etc. So what led to this change from that Middle Ages to today's view? It's really the Enlightenment and the use of science and technology. And so the things like the microscope and the foundations of modern chemistry appeared in the 17th century. By the 18th century, we were starting to think about vital signs like pulse and blood pressure. The X-ray appeared in the 19th century, very late in the 19th century. And the ECG and EEG, monitoring things like your heart and your brain, appeared in the early part of the 20th century. The rise of computation, and I'll say a little bit about that, really transformed these kind of basic inventions into whole fields of medicine. So I'll give an example, the X-ray, looking at what's going into the body. There's this whole field now of medical imaging with CAT scans and MRI scans and PET scans. And there's been probably half dozen Nobel Prizes in physics awarded for the discovery and application of those technologies. And those technologies are only possible because we have the computing power to take the data that those scanners produce and create an image out of it. The X-ray, you know, the image was sort of made for us by the radiation. Medical imaging has completely changed, where we reconstruct the image inside of a computer. And that's true for sort of all of these areas you see on the right side. The pathology has changed, the way we monitor patients has changed, the way lab machines work has changed. So when I say the rise of computation, I really am referring to the fact that almost every item in healthcare has a processor inside of it that's doing some type computation. It may be the scanner that's reconstructing the image. It may be your electronic health record here on the bottom left, where all the data about your visits to different doctors is kept. It may be a lab machine that's doing chemistry. This is actually the COVID-19 test machine from Abbott Labs. And there's computers in there that are helping get that test result quickly. Or it may even be your own device, like your smartphone, where you can have a little EKG device like this in the home and put your fingers on it and see if you're having atrial fibrillation. My Apple Watch now does that. So this rise of computation and computer science really changed the way everything happens. So where we're going next, I'm just going to talk about 3 or 4 examples, and then we'll dive into the questions. There's 3 things that are really, in my mind, driving where we head next. The biggest is just the raw power that we now have available to us from a computing point of view. The supercomputer that was at the university when I was getting my PhD has, my iPhone today has more power in it than that supercomputer, which filled a room, had in 1994. As a result of all that power, we also have much more data. The amount of data we're generating on a daily basis is huge. And the insights that we can mine out of that data are profound. And then finally, the whole area of artificial intelligence and machine learning, it depends both on computational power. It depends on the availability of really nice data sets for machines to learn from. But that has profound implications for where healthcare is going. And so 3 examples, and I'll talk about each one of these for about 1 minute, and then we'll dive into the questions. Basic science is going to be transformed. So understanding the fundamental nature of disease. And that may include things like genetic repair for people who have genetic disorders, discovering new drugs, or even researching whole systems in silico rather than so in a machine, looking at a simulation. Then the clinical research, the research that involves people, is going to change. And that's going to be the way we design clinical trials, the way we support and monitor patients when they're in a clinical trial, and ultimately what kind of data we collect and report back to the regulators with a clinical trial, called a phenotype. What do we observe? We're increasingly going to observe more with digital tools. And the phenotype is just what's observable, like your eye color or your hair color. And then digitally, we're going to observe things like how well people sleep or how much they're moving around. And then in clinical care, systems are going to help with diagnosis. They're going to help with monitoring patients. And increasingly, we're finding that digital tools can be used therapeutically, almost prescribed like a medication. So for people with addiction disorders, they have apps that help them manage their sobriety, and they've been shown to have therapeutic efficacy. So basic sciences, genetic repair. The big news here, and I won't go into this in detail, is something called CRISPR. You can think of CRISPR at a high level as search and replace for genes. So just like you can search and replace in a word processor, CRISPR lets you target a gene and it may be defective and replace it with something that isn't. It's been shown to be beneficial for all sorts of things in animal models, including like ALS, Lou Gehrig's disease in mice. But you really, if you're going to search and replace in a gene, you better make sure you're getting the right thing replaced. And there's a lot of computational power needed to do that planning and that design for search and replace. And companies like Microsoft and others are getting involved in tools to help CRISPR work better. My company is in the clinical trial space. We do a lot with clinical research. And increasingly, the data isn't just from the patient in the trial. There's whole sources of what are called real world data. So an example here, breast cancer is very rare in men. It's very hard to run a clinical trial and get something approved on its label for use in men. Pfizer had a blockbuster drug a couple years back approved for women called Ibrance. It was used off-label in men, and they were able to take that electronic health record data, not from a study, just from the treatment of those men, combine it and show that it was beneficial and get approval from the FDA as an on-label use without running a trial. So this is an example of the power of this data. On the care side of the world, there's computers that have been trained to assist radiologists in reading scans. They point out what they think may be problematic areas, and the radiologists look more carefully there and verify and decide, is that right? Or is there something else I'm seeing the computer didn't that I should point out that gets learned in the next set of data? And finally, this is an actual project. The CTO of my company was at IBM with me. She was a senior leader there. And this is a project she did. I'm going to run this 30-second commercial, and we'll see how this works on Zoom.
This is a baby generating data in a neonatal ward. Every heartbeat, every breath, every anomaly, from over 1,000 pieces of unique information per second, helping doctors find new ways to detect life-threatening infections up to 24 hours sooner. On a smarter planet, analyze the data and you can predict what will happen faster. So you can do what they're doing in Toronto and build a smarter hospital. Let's build a smarter planet.
So, you know, that monitoring, they could predict in preemies, sepsis and other really bad conditions 24 hours before they had serious symptoms. And you can save a neonate's life if you can do that. So, so better basic research, better studies, and an application of technology to trials, to care. I'll close by saying this. There are problems that technology won't solve. We know that when we have a wonderful capability like these, they're not widely disseminated. They're not equitably disseminated. We know that our healthcare system as a whole isn't functioning. It's not healthy. And we also know that when we take this biomechanical view of the human, we often ignore the experience of the person dealing with the illness. We're so focused on the tech and the illness that the care of the whole person gets lost. And the American Medical Association and a lot of people are actually looking at that problem carefully and asking, what can we do here? And the real need is around meaning. Meaning matters to human beings, and being able to talk about the experience of an illness and what it means to somebody and how they feel about it is very important. And in the age of compressed appointments, because our system isn't working well, that gets lost. And so I think that's where we I'm going to leave it there, but that's where those of us who have a spiritual home and a spiritual discipline and spiritual practices and participate in this world have to bring that perspective. So I'm going to stop sharing, Peter, and we can have the discussion and open it up to questions. And I'm happy to dive in.
Great. Please do send in your questions. You can use the live chat function on YouTube, the comments function on Facebook, or if you prefer for your question to be more private, you can send that to me, pthompson@stbarts.org. That's pthompson@stbarts.org. We've actually got quite a few questions already. So clearly this topic has really interested folks. As we're waiting for more of those questions to come in, I'm wondering if you can talk about some of the downsides of tech. Obviously, you focus mostly on the positives. We talked a little bit about the downside of kind of neglecting the whole person who's involved, segmenting parts of the healthcare experience. But there are also, concerns about privacy, about the monetization of data, that kind of stuff. Can you touch on those areas?
Yes, absolutely. So I want to talk about actually 4 downsides that are. First is privacy is a huge one. So we live in an era where data is the new oil, if you think about it. There's this rush to mine data, to monetize data. This was driven largely by the way companies like Facebook and Google work, where those of us who use them feel like, oh, this is free to me. This product is free to me. But the reality is Facebook is not the product, you are. Your data is being collected, encapsulated, monetized, sold, used for ads, whatever it is. In healthcare, this has profound potential consequences that are everything from evidence of insurability. So I'll give an example that I like to use. If my genetic data shows that I have a propensity for colon cancer and I had a child, could they get life insurance if that data was mined and used in some ways to make it seem that they weren't insurable? We're in the health side, we're largely prevented from now writing big exclusions, but there's all sorts of other ways this data can be used nefariously. On the basic science side, some of you may have read about a year ago about the use of this CRISPR technology when a scientist in China went rogue and actually used it in a human embryo and then implanted it. It became a baby. And nobody knows what the implications of that are going to be. So the ethics community is really wrestling and looking at how these technologies need to be vetted and figured out. But you have one scientist who does something like that, and it's really quite frightening. And then the last one I'll leave people with is just technology drives enormous cost in the healthcare system. And if it's often used aggressively, very aggressively, and this is a whole area of billing and how doctors are reimbursed and how hospitals make money, but it's often used very aggressively in the final few weeks of life. And so we spend enormous amounts of money on just a very short period of life. And we haven't wrestled with that question from the ethics point of view in a way that's informed the system. The ethicists certainly know that and they're thinking about it, but it has not informed the way our system functions.
And you're sort of uniquely qualified to evaluate ethical issues in this area because you have the subject matter expertise and the theological training. Can you talk a little bit about how you recommend folks in the health tech area navigate ethical issues like these? What should guide them?
So it's really important, first of all, one of the nice things about healthcare is that they have professional ethicists sort of positioned throughout the system. So in the area I'm in, there's what's called Institutional Review Board, IRB. They review studies to make sure that the participants in those studies are going to be treated well. And they put out guidelines. We have an IRB chair, former IRB chair in our company as the head of research and regulatory. They put out guidelines to help people think about, how do I get my study approved? When it comes to sort of the theological aspects of the ethics, we need to have, and this is just a conversation that became a third rail during the whole rollout of the Affordable Care Act. We really need to have deep conversations around aging and end of life, death and dying. And those are conversations that people prefer to defer and avoid. Coming to terms with sort of what I call the Ash Wednesday reality of the world, remember you are dust and to dust you shall return, will serve us well when it comes to navigating and starting the the patient-centered conversation around these ethical issues. And so the spiritual communities all have something like that. In Buddhism, there's what's called the 5 remembrances. And they are: remember that you will get old, you will have illness, you will die, and you will be separated from what you acquire, and that your actions here matter. And so it sounds a lot like, remember it's memento mori, put death before you. It sounds really like a downer, but it can actually be quite liberating if we deal with this aspect of our lives in a straightforward way. And it will lead us to a better use of our tech.
Can you talk a bit about the role of technology in combating COVID-19 and some of the things you've seen in your field in the past few months?
Yeah, so it's the use of tech with COVID has been largely a success story, burdened by the divisions in the country, the suspicions about public health, the lack of everybody feeling we're in this together, sort of the lack of clarity around what we should or could do. So when I look at the tech around COVID, I break it down into a few sort of buckets. One is, and this is my area of expertise, so I'm prone to like it, but the whole area of modeling and trying to predict what's going to happen and trying to understand what the effects of interventions may be. So the models being built at the Institute for Health Metrics and Evaluation at the University of Washington, at Johns Hopkins, the consensus model being built at CDC, to try to look ahead and say, what's happening? Where is it likely to happen? What do we do? That the models themselves have largely been very informative. The ability to act on what we've learned has been impaired. On the vaccine front, nobody 10 years ago would have believed you could identify a new pathogen at the start of the year, understand its genome within the first month, and have a vaccine out by the end of the year. And that involves just huge amounts of work on both the basic science side of the world, synthesizing these mRNA vaccines that Moderna and Pfizer have released. The way the trials were done, they adapted, to get these trials, try to get these trials done quickly so we could have confidence that we could start vaccinating people. And then I believe the questions around follow-on, which really needs to happen, are being addressed. I don't know that they're completely addressed yet, adequately addressed, but I think they're really trying to. And last but not least, when science tells people, we've learned something new, we said X and now we're saying not quite X, do Y. That's a good thing. That is not a failure. It's not a political act. It means that we're learning something about how this disease behaves. And so I would say from the basic science, from the clinical science, and from the public health foundation's point of view, good things happen. From the public health, the issue of policy and politics and the dividedness of our country, we've really suffered.
In other countries, there's been more extensive use of kind of tracking with mobile phone data and using that to combat COVID-19, impose quarantines, et cetera. Do you want to comment at all on that practice?
Yeah, I do. So for people who don't know it, there's an app called COVID-NY. It was jointly designed by Google and Apple, 2 companies that don't normally work together, by the way. And the big question here, and it goes to the ethical issues Peter raised at the beginning, is if we're going to track people, if we're going to try to use technology to identify, track, and trace, how do we do that in a way that preserves privacy? Because when a contact tracer calls somebody on the phone, there's a lot of guards around making sure that they say things carefully so that privacy is preserved. These apps are now available in all 50 states in the US. They have not been widely publicized for whatever reason. And what's interesting is they don't know who you are and they don't share your location. So they are able to track who you've been in contact with in a privacy preserving manner. it has not taken off here for whatever reason. Now, there's limited utility to getting an alert on your phone that says you were with somebody for 10 minutes who has now tested positive. Because if there's a huge outbreak, you just may find out I was around a lot of people who tested positive. But in places like Japan, in South Korea, et cetera, in Taiwan, where they have been very aggressive about using both tech and sort of standard public health measures, applying them quickly and aggressively, and tamping down the fire before it gets raging, they've been able to live a more normal life than we have. So there's a trade-off here. You know, there's a trade-off of, yes, we will give up something, hopefully not all of our privacy. Let's do our best to preserve that. But the perception that this just has to rage through the country is false. That is not what needs to happen. We will have a more vibrant economy and better human outcomes if we contain this.
Here's a question from someone who has a lot of experience in the healthcare field, who is wondering about efforts to reform healthcare and their impact on reducing funding for innovation. Is that something you see? Any comments on that?
You know, the whole question of how you fund innovation, how you fund research, and whether we're funding the right research, you know, this is almost a perennial problem. The efforts at reform. So I'll give an example, and this is my opinion. This is opinion as opposed to fact. So when HIPAA was passed in the late 90s, one of the big concerns was insurability and trying to make sure people weren't denied insurance if they moved from one plan to another. There needed to be portability. There needed to be a way to continue to cover conditions. But if you look at the world of data, there's a lot that HIPAA gets in the way of that could be done in ways that are appropriate, respectful, and private. It makes certain things hard that don't need to be hard anymore. HIPAA hasn't been revisited in 20 years, really, in any significant way. And that's a long time if you think about tech 20 years ago and what we could do. When it comes to funding, you know, if you look at the NIH budgets, they place some bets that really pay off. So like mRNA vaccines, that bet paid off in spades right now. That was building a vaccine platform on RNA technology, which a lot of people were dubious about. Turns out was a great bet. There are efforts around HIV vaccines, not so much. You know, there's been 40 years of effort now, nearly, and we don't have anything. How you do that, how you identify, there's actually, believe it or not, computational machine learning techniques applied to early papers to try to say which research is likely to be most fruitful based on how people pick it up and comment on it. And there are patterns. So we may be able to even use machines to say something to start to score or give a partial score to research proposals and papers. But last comment, how you identify what to work on and how you convince Congress how the funding should be allocated and how it should be, where there should be restrictions, where there shouldn't be restrictions. You know, I'll give an example, controversial. It's a travesty that you cannot do research on firearms in the United States. The fact that they tie the hands, federal research dollars are very limited in how they can be spent on that kind of research. It's just not right. So how you get the funding mechanisms aligned with the needs it's a perennial problem.
So someone else with experience in the healthcare field brought up the phrase medical informatics and wonders if you can speak a little bit about that.
Yeah, so my time at Columbia University before I went to IBM, I was in the Department of Medical Informatics, Clinical Information Services. So medical informatics, at its sort of most foundational level is the most fundamental application of it today is the EHR, the electronic health record, where all of your lab data, your pathology data, your doctor notes, all of that information flows into a common place. Now, what can be done with that data is very, informatics in general is about how you gather, manage, and use information. That's at the core. It's about collecting, managing, which includes making sure it is of high quality, and then applying it. And so bioinformatics, medical informatics, there's a set, clinical informatics, they'll talk about that. There's a set of use cases that are really driven by informatics. And at the core, what really has to happen is there has to be a lot of standards. So if you want to use information across the country or around the globe, things like you need to be able to recognize that a drug that's named one thing here and only the generic name there is really the same compound. So there's what are called coding standards that let us collect the data and put numbers, associate numbers with everything from diagnoses to complaints to medications to treatments. And then all of that data then becomes standardized. It can then be analyzed in ways that let us find patterns, trends, even do research on it. So, we have data from 10 million patients across the US who've received cancer care. Do we see any patterns that are unexpected in that data if we do machine learning on it? And that data can be de-identified, so none of the patient identity is in it. And then you can run these algorithms on it to see if there's something surprising there. So medical informatics is really that broad field of collecting, standardizing and managing, and then using data in these ways. And it crosses a lot of different domains of healthcare.
You touched on health inequality, and to what impact do you think access to technology may have? What impact may access to technology have on that health inequality?
I think it's really a substantial piece of it. It's not the first piece we need to tackle. The first piece are really the core social determinants of health, which are not technological. Usually, they deal with, secure housing, access to clean water and good food, access to places to move and exercise safely. So the safety of the community, access to, you hear about food deserts, places where people don't have fresh vegetables, for instance, available in the grocery store, or the means to buy them if they're there. So there's these social determinants of health that are sort of the foundation that a community needs to look at when they talk about health. And then once you start to move up, it's almost like Maslow's hierarchy of needs. You have to have these very basic needs met. And at some point, as you move up that hierarchy, things like access to technology can really help people make healthier choices, take better care of themselves, to avoid illness. So I'm wearing two wearables right now. I have a ring on and an Apple Watch. And I actually get a lot of data off of those that I track. And then, so that's the real goal, is can we help people avoid getting sick in the first place? Can we help them avoid encounters with the healthcare system? And then once they have an encounter, the hospital that is in the urban neighborhood that's not affiliated with a major medical center, that may not have some of the latest EHR technology, the latest scanners, et cetera, those patients will almost certainly have a different outcome, a worse outcome than patients treated at a major medical center with modern equipment and the latest and greatest capabilities. And that is really, truly in our country segmented socioeconomically by neighborhood. So it is very important for us to address both the foundation, the questions of social determinants, and then the technology that can ride on top of that and help people stay healthy and then have the best outcome possible if they have an illness.
You talked about technology perhaps raising the cost of healthcare in some circumstances. Are there also circumstances in which technology can help lower the cost of healthcare?
Yes. So identifying what really works and whether there are, and this is also where the ethicists need to weigh in. If you get a sliver of improved outcome for an enormous cost, there's a social trade-off there. Do we want to put that sliver of outcome ahead of many other things that need to happen? So that whole informatics area I talked about, where we can collect this data, we can mine it, we can look for both how were people treated and what were their outcomes, and we can begin to understand the evidence that underlies certain treatment patterns, certain ways that people are managed in the healthcare system, and we can answer the question, what is the most beneficial and cost-effective approach that we can take to managing this disease? And that's typically as far as many people get. I think there's another question we need to answer on top of that. So what is the most beneficial, cost-effective approach? And then what are the alternative paths for those people who don't respond on that path? How do we not, I don't know if any of you ever dealt with getting something approved that was denied by your health insurance company because it didn't fit the standard of care. It's an unpleasant process. How do we identify those what I would call common outliers and not make them go through, hoop jumping, so that the paths are, the care journeys are not just here's the one that works, but here are the alternatives as well.
There's a question about the possibility of technology in healthcare creating communities. Someone has the similar condition and you're able to find one another through technology. I'm thinking also of kind of 23andMe, which is allowing people to find people they're related to, but also talk about issues of healthcare. So any reflections on that?
I love this question. Yes, and it's what you do. So there is a patient community called Patients Like Me. I forgot who bought them. It was one of the some big health institution bought Patients Like Me. But the goal was to create basically a community where people could chat about their conditions. And then the challenge there is to moderate those chats and make sure that they don't sort of go off into areas that have been shown to be, either untrue, like anti-vax sentiment, or other sort of discussions that aren't medically indicated about what people have. And so those communities are often moderated with doctors or nurse practitioners who can answer questions. What we've heard, so we run a large observational study for the Metastatic Breast Cancer Alliance. And what we've heard from metastatic patients is, they like to know, first of all, who else is in the study. And believe it or not, a lot of registries don't let people know who else has been here and what did you learn. So we publish that information back to patients so they can say, look, this person is not on a person by person basis, it's statistics, it's charts and graphs, but look, there's 250 people in here who are like me. And then we're setting up a registry with another cancer foundation where they're actually going to use what is collected to create communities. They're going to connect patients to each other explicitly. In clinical trials for drugs, that's harder to do because you could end up biasing the trial or doing something. But in observational studies, it's really interesting. And then, of course, as you move to care, it becomes even more interesting. And I'll say one more thing here that's really important. Because of the genomics revolution, the Human Genome Project, we decoded the genome a couple decades ago now. And we're starting, like, what used to be considered breast cancer is now, many different diseases based on genetic subtypes. And so what this means is that actually these diseases start to look like rare diseases. The people who have, triple negative breast cancer or other types will be in a smaller set, and they want to know who each other are and find each other. And so engendering communities are really important things that some of these platforms need to start doing.
There's a question about security of data from hackers, and obviously healthcare data is often particularly sensitive, perhaps just as, if not more sensitive than financial information. So what is your field doing to protect data?
So when you look at data security issues, so first of all, I'll talk about our company. We use the latest encryption technologies on the phone. So we collect data from patients on the phone as the data is in flight to the servers, and the data is stored encrypted on the servers as well. Most security incidents, and this is what's not talked about a lot in the press, are not huge flaws in the technology. They can be there. They're huge sociological flaws in things done inside the company. Somebody sets their password as PASSW0RD. One of the big hacks that just happened that you read about with the government, one of these private companies involved had a bad password like that let people into the back door. So these are the biggest holes a company faces are the human failures. And so finding ways to educate, to detect, and to prevent those kinds of human holes needs a lot more attention than it has today. And then when it comes to security, we've got to get out of a defensive posture where we're trying to fend off people and go into more of a posture, I don't want to call it offensive, but a proactive posture where we're really understanding where threats may be and taking measures against those threats before they start to poke at the system. And that is harder. There's a lot of security folks who are thinking a lot about that. And I did see a few of the government leaders talking about the most recent hack, saying we have to stop just defending. So that's actually really good to hear. But the human side of security is really the soft underbelly of the system. And in healthcare, it means that people need to be trained, that systems need to be monitored to make sure passwords are secure, et cetera, and that we need to detect very quickly if people are vulnerable to exploit.
Are there ways in which technology can assist primary care providers and minimize the need for specialists? Because so many Americans rely heavily on specialist providers.
It's a great question. Probably so, but I would say it's nascent right now. So the goals with things like taking the IBM Watson computer that played on Jeopardy and trying to apply it in oncology, what the teams that did that sort of thing discovered is that it was not as straightforward as they hoped to have even really good AI and machine learning based systems perform at the level of a top specialist. And so one of the questions that they are trying to answer is, what does it mean to assist somebody who's really skilled in the field, who knows medicine? Could these systems help them find the right thing to read or the right recommendation more quickly, rather than trying to make the recommendation themselves? So I think that it's possible, but it's very nascent in terms of where we are today. There's a lot to learn on the computer science side.
Okay, I'm going to try to fit two more quick questions in. There's a question about the International Space Station. Have there been any experiments in space that have ramifications for healthcare? And there's also a question about blockchain technologies and how that could transform the healthcare field.
Oh, great questions. On the International Space Station, I can't name an experiment that has transformation, but I can almost guarantee you there has been. It's they've looked at things like crystal growth and other processes that involve what happens at low gravity. And I would be surprised if there wasn't something that was discovered there that may have a ramification for healthcare, but sadly, I can't tell you what it is. Blockchain, blockchain in theory could be really transformative, but once again, there's a sociology around blockchain that needs to, so for those of people who don't know it, blockchain, it started with all these cryptocurrencies like Bitcoin, and it's basically a privacy preserving public ledger so it has transparency. It can never be changed once something's written to the block. A block is written to the blockchain. It can't be changed, so you can't meddle in it. There's a lot of security stuff. And in theory, it could be a way for things like patients to share their data selectively with other organizations for research purposes, et cetera. There's just, if you look at the public understanding of blockchain and the healthcare system being amongst the most conservative movers, financial services has kind of struggled to adopt blockchain broadly. Healthcare is going to be way behind them. So there is promise, and there's promise on both the research, really on the research side and probably on the care side, but we're going to go from the peak of irrational exuberance where technologies get really hyped into the trough of despair before we come up and find out really how it's useful. So I think we have a journey to go there.
So the questions are still streaming in, but unfortunately we have to come to a close. I do want to ask at the very end, we've touched on ethical issues, but if you can talk a little bit about how the fact that you're a seminary graduate, how that influences what you do now, and maybe a little bit about the class you'll be leading in January on the intersection of science and religion.
Sure, absolutely. So, when I founded Medaptive and when we started pulling together the team of co-founders and our employees, what was really common, and this is easy to say, a lot of companies say this, but it's really actually true for us coming out of seminary and other backgrounds. What was very common was we had a mission. We looked at it and said, it was vocational. It was not career aspirational. If I had wanted to be career aspirational, I would have stayed at IBM and kept climbing up the ladder. It was vocational. It was like, I need to do this. I myself had been involved in a clinical trial that was very important to me. And I understood both the benefits and the loneliness of that process. And we started asking questions. How do we make this better for people who have a challenging condition and are in this really scary, uncertain situation called the clinical trial? And so the mission of the company quickly became rethinking the trial through the eyes of the participant, the patient, and trying to make sure their experience of it was as safe and comfortable as it could be, while also getting the pharma companies running the trial the data they need for new cures. So that's my seminary. I hope you can see where that comes in there, that notion of vocation. And then the class that's coming up in January is Science and Theology. We will be looking at origin narratives to start. So what the Bible says about the origins of life and humanity, what the narrative from science is. We'll talk some about physics. The Star Trek people usually really love the physics piece of this. We'll then switch gear to the origin of life and biology. And then we'll close with sort of a spiritual, it is a meditation on what all this means together. So it's a set of sessions that sort of walk through those topics. So the biblical narratives, the narrative from physics, the narrative from biology, and then the spiritual ramifications.
Excellent. And this will be Wednesdays in January. So I hope you all will pay attention to your e-news and you'll get more information there. You can tell that Clay brings a lot of expertise and passion to this area. And I hope you'll join us for that. But for now, thank you so much, Clay. This has been such a wonderful time together this morning. It engendered a lot of discussion online, so I think this has really resonated with folks, and I'm really grateful to you for taking the time to be with us.
Great. I really enjoyed it. Thank you for having me, Peter.
Thank you all for watching. Please join us for worship at 11.